guys. Gosh, it was nice to see you guys today. I know you're seeing this tomorrow, but for me it's today, and it was so nice to see you guys. It's hard when I'm teaching to a phone. It's much better to know that I'm teaching to kids, and I can't wait for tomorrow when we get to read The Secret Garden together. But for now, let's talk about math. Before we even talk about today's math lesson, I want to go back and I want to think about something that we have talked about and something that Mrs. Kling has talked to us about. I want to talk about, let's say, 8 times 4. And if you aren't, let's just say 8s aren't your best number, okay? We've talked about how instead of 8 times 4, you could do 5 times 4 and 3 times 4. If you know 5s, because those are easy, right, is 20. And if you know 3 times 4 is 12, then you could just add those together, right? And then we would know that 8 times 4 is 32. Okay, so we've talked about that before, where that's the thing with multiplication, is that you can break it up and you can put it back together. That's the distributive property, okay? And it makes it really easy, because if you don't know 8, you could break the 8 into 5 and 3. And as long as you continue doing it that way, you can add those up, okay? We've done that before. Let's do another one. I think, get my little papers back here. Let's do another one. Let's do, let's say 9 times 6. Okay. Now, last time when we did 8 times 4, we broke up the 8. We could break up the 9 or the 6. Okay, so let's say that you know 3s. What if you did 9 times 3 and 9 times 3? Okay, your 9 stays the same, but instead of doing 9 6 times, you're doing 9 3 times plus 9 3 times. And we can really understand why that would work, because 3 times plus 3 times equals 6 times, right? So if you know that 9 times 3 is 27, and 9 times 3 is 27, right? So you add your 20 and your 20 is 40. Your 7 and your 7 is 14. 40 plus 14 is 54. Okay? So with this in mind, I'm going to erase just this bottom part. And I want to ask you a question. How can I use this to understand the area of a rectangle? I want you to think about that for a minute. How do I turn this into area? Well, I said rectangle, so I know that I'm going to have 2 long sides, right? And I'm going to have 2 short sides, right? Because I said rectangle, and that works with this, doesn't it? So my long sides will be 9, right? My short sides will be 6. Okay, so I already know the answer, right? But do you remember how we broke that up? We said that 9 times 3 and 9 times 3 was equal to 9 times 6. So now my question is, could I break up my rectangle to show this? And if I did break up my rectangle to show this, what would it look like? 9 times 3 instead of 9 times 6. So here's my 9. Here's my 6. How do I break that 6 into the 3's? 2 of them. Is this what you're thinking? I didn't draw it very well. If I break that 6 in half, did it turn into 3 and 3? Is that correct? Does it make sense? Not just, hey everybody, remember this is how you can do it, but does that make sense to you? That it would be 3 and 3, and that would be the same as this line being 6. So what now? Let's see. The area of this guy is what? Let's see. Area equals the length times the, the length times the width. Width is wide. Remember the W, width means wide. So area equals 9 times 3. Sorry. It wasn't a 7, it was a 9. Okay, and area equals 9 times 3. If I add these two areas together, do you suppose it would equal the area of 9 times 6? Let's see, 27 and 27. Well, 20 plus 20 is 40. 7 plus 7 is 14. 40 plus the 10 is 50. Plus 4 more is 54. So isn't that interesting that I could take my full rectangle, break it into 2 smaller rectangles. I could still represent the 6 times 9. I could represent the 9 times 3 and 9 times 3. I could still end up with the same area for the whole thing and the same thing we came up with when we were just trying to break it up. So look how, once again, boys and girls, we took something we learned several months ago. Remember we talked about the stair steps? We took that information and we used that information to learn something new again. You see how we keep doing that and doing that and doing that? That's the example of how every single thing we learn in math or in any of our subjects is so that we can apply it to learn something new with our next subject. Sometimes it's so that we can learn something new in 4th grade, but sometimes it's so that we can learn something new in 3rd grade. All right, let's do another one. This one we broke up evenly. So we broke that 6 evenly into 3 and 3. Let's look at one where we don't break it up evenly. Let's do, let's see what our math book shows us. So this is 14.5, I believe. Let's take a look at this guy. So we're going to call this 4 and we're going to call this 5. Okay? So 4 times 5 equals 20. I don't have units on here. I could put in inches, I could put in centimeters, any of those would work. And whatever was here needs to go here, okay? I don't have any units here right now, so I'm gonna have nothing right here, okay? I just really wanna talk about the numbers right now, okay? But what if all of a sudden I needed to share whatever this is? What if this is a graham cracker and I need to share this? Okay, I'm going to do this. Last time we shared it this way. I want to just try sharing it this way. So you notice that I didn't go in the middle. So instead of this 5, what's your best guess about this side and this side? Did you guess that this was a 3 and this was a 2? Makes sense, right? All right. So now, if we're going to figure this out, I'm going to move this up. And let's move this up here. That's what we started with. Now I want to look at what is the area of each part of this graham cracker. So let's look at this area. Let's see. Area equals length times width. So we're going to do 4 times 3. Area of this graham cracker is 12. Now, of course, I'm not going to use the 5 because I've changed that 5 into a 3 and a 2. Because I know with my properties of math that I can break numbers up as long as I don't add more or take any away. Okay? So now I'm talking about this area being 4 times 2. So this area plus this area should equal this area, right? Because if I have a graham cracker and I break it right here, as long as I don't take any away or add any in, it should equal the same thing as the whole. That just makes sense, I hope. Okay? So let's see if this area plus this area equals the area of the whole thing. Now, you know me, I'm a make-tenner, so immediately my brain sees the 2 and the 8 and sees a 10, right? 12 plus 8 is 20. So the area of this plus the area of this equals the area of the whole thing. And that makes sense because I didn't add any graham cracker. I didn't take any graham cracker away. So it makes sense that this and this would equal that. Okay? So let's look at the pages for 14.5. When I look at the reteaching side of 14.5, I think it looks a little bit confusing. Okay? So I don't even necessarily want us to focus on the way that they've shown us to do it. If you look at the top row for number 1, it gets a little bit confusing. But look down at the bottom row. Hopefully you can see this okay. Maybe if I don't know where to put it. I think if I look up here, it gets a little bit confusing, but it really doesn't need to be confusing. If I'm just thinking about the 3, you know what's funny, Ryan, is that your brother did the exact same thing. If I just look at the 3 times 3 is what I have here. And then if I look at this, I've got the 2 times 3 is what I have here. And all I'm doing is adding them together. Okay? Let's disregard this top row. Okay? I don't want to make this any more confusing. It doesn't need to be. It's really quite easy. Okay? So let's look at number 2 together. And then I'd like you to do the reteaching side, or the practice side. Let's do the reteaching together. Okay, so if I look at number 2, I've got a great big rectangle. Okay, but this rectangle is broken up. right about here. It's not an equal break. Again, I want you to think of this like it's a graham cracker, okay? So if I count the squares, I didn't draw in squares because you don't have to have squares, but you see squares there. So what is this line for number 2 on 14.5 reteaching? R. What's the total of this amount? Did you say 3? Okay, 3 squares. This is equal, which means this is 3. Okay. What's this line? Did you say 4? Okay. This is equal, right? What's this one? Did you say 4? This is equal, yes? And what's this one? 4. Okay. So you might immediately be thinking, well, gosh, Mrs. Mandeville, I'm just going to do 7 times 4 because I know 7 times 4. Excellent. That's good. But we have to be able to break it up. And why do we have to be able to break it up? Because, boys and girls, do you remember when we did this shape? Remember when we did this yesterday? Was it yesterday? Friday? Let's see, today's Tuesday. I think it was yesterday. We had to be able to break that up. So we have to learn how to break it up. Okay? I'm going to get rid of that. I'm afraid this is going to tip right over. Okay, so let's figure this out. Again, boys and girls, let's disregard this top row. Let's just look at the bottom row. This is the small one plus the square is equal to the total, right? Okay, so the area of this guy, area equals how long it is times how wide it is. And we've talked about why that is. So area equals 4 times 3. Area equals, did you say 12? Area equals 12. Okay. The area over here, now we're lucky here we've got a square. So what does that mean? It means all 4 sides are going to be equal. It's not a square if all 4 sides are not equal. If all 4 sides are equal, it automatically is a square. Okay, so the area would be 4 times. Basically like 1, 2, 3, 4. 1, 2, 3, 4. Okay, so this area equals 16. So if I take this area right here plus this area, 12 plus 16, 10 plus 10 is 20, 2 plus 6 is 8, 28. Let's check that. Let's see, 3 plus 4 equals 7. So this line is actually a 7 when I add the 2 together, right? So the whole graham cracker is 4 times 7. What's 4 times 7? What a great way to check your work, don't you think? 4 times 7 is 28. So there's a check for your work. It's perfect, right? Okay, I'm hoping that with me you're kind of thinking, oh man, this is easy. I know exactly what I'm doing. So I'd like you to do 14.5 practice page, okay? And when we get together to read today at 11, on Wednesday at 11, I'd love to hear how that went. I'm hoping you're clicking right along with it. But please ask me questions when we meet for reading, because I really want to be able to help you through that, okay? Really looking forward to reading with you guys at 11. So I hope that you can join us. If you can't, I'm going to figure out how to send you the recording. Otherwise, it's a very short chapter, and you can read it on your own and do the comprehension questions for it. It's a good one, so I think you'll like it. It's another one where Mary and Colin kind of butt heads because they're so much alike, actually. Okay, I'm looking forward to seeing you tomorrow. Bye, guys.